Hello there, Rigo here. Just a quick video to show you how to set your environment in ADS quickly in order to make a simulation, optimization or tuning. So first, create a workspace. Give it a name and click on Setup Layout Technology immediately after creating the library. Here I know my Gerber files used millimeter, so this is the option. And there you go. I have here my workspace, but it's empty, so let's import the Gerber files. Select here Gerber, and before selecting the files, give the cell a name of your full PCB with Gerber. So I'm gonna call full PCB. Here's important to select all the metal layers. So you know I use KiCad, back copper, front copper, and plated through hole. No need to select non-plated or silkscreen mask, etc. Everything went away okay. So I have a full PCB. In order to minimize simulation time, let's crop this PCB into a smaller version. You can see here I have my RF network. If I'm not mistaken, this is an inductor in series, capacitor in parallel, and here's my connector. So I don't want to simulate all of this, I just need this guy and its close vicinity. So draw a rectangle right here. Press escape, click on the rectangle. You can adjust just to fine tune the size you want of this rectangle. I think this is okay. With the rectangle selected, press crop. Click OK. And now you have the connector and its vicinity. So let's save this guy as a new cell. Cropped. And now we have the selected part of a PCB we want to simulate. Now we need to put pins on it in order to simulate with components. So in order to create the pins, I'm going to select here, insert pin, and be really careful with the layer selected. Here the arrow is red, so it's probably on the back layer. I want to be on the front layer. So now we're in the correct layer. I'm going to create the input right here. So I know now there is an inductor in series with this trace, so let's call it L1 pin 1, and it automatically switched to 2. There you go. And now I have a capacitor, so C1 1 right here and 2 right here, and the outputs. That's it. We created the pins but didn't have a reference, so you're gonna have to click right here in port editor. I'm gonna increase the screen. There you go. So now each connector will be highlighted in case you need to know who's who here, but the important thing is in the ground layer, just make this bigger, you can use the back layer and all of them in case they have the front and the back layer under the pin you clicked, of course. After all this is done, you can click, and now you have pins assigned in your PCB. Of course you have these Gerbers of this PCB, but these Gerbers represent layers you're gonna manufacture. They have physical properties. So in order to configure the substrate, let's come here in the, of course, substrate editor. There's no substrate file yet, so we're gonna create one. I'll leave it right there. The templates, here in my company I use 2-layer FR4. Now, this is the template I used. I don't need this intermediate here, so I'm gonna click on this and delete with the lower interface. I don't need the interface in there. Or you click on the dielectric below and delete with the upper interface. The important here is I only need one dielectric, two conductors. So I attribute this layer here to my front, this layer here to the back copper, and the vias, of course, use the Gerber files for the plated through hole. And now you need to configure the thickness. This is the part you contact your manufacturer for the exact specifications. The manufacturer I call here for a 1.6mm board. It gave me 55 microns here, 35 microns here. Apparently when they plate the holes, increase the thickness a little bit of the front layer. And here it is a total of 1.53. That's it. Save the substrate and close. Now let's configure the simulation. Click here in the EM. There's no simulation file, I'm gonna create one. No templates, okay. So I already configured the substrate and ports, frequency plan. So here I'm gonna configure this for 800 megahertz to 1 giga. That's fine. After you click here in model and ensure the model exists when the simulation is launched, really important. And to finish, come to options. First, physical model here, and I like to use a thick conductor as a 3D, simulates as you know. You can see here the drawing, you have a three-dimensional copper layer, and for a via, the simple wire to save us some time while simulating. After that, you go to mesh. Net specific, because I don't want every single net to have an ultra high definition mesh. So keep things side by side here. It will highlight the net we're about to configure. So this is the ground layer apparently. Can we keep on the 20? But the main ones I like to put 60. Give me higher resolution. That's it. So now we're ready to create a mesh model for this board. Click here on mesh and go. It takes some time, so it's time to relax and stretch your back a little bit. Oh, here's just telling me that my path is too long. We create temporary, no problem. So this is done. Close this. Okay. Let's just save everything before I go and create the S parameters. This will take a lot longer than the mesh, so now you can just, grab a coffee, get up from a chair and stretch a little bit more. So here you have the preliminary parameters for the simulation. You can basically close this. Okay, and close, save, have here the mesh, and close this. Now you have the cropped full PCB. Now I'm gonna make a symbol for the cropped one. You can simulate using components. So create the symbol here, choose the cropped, and create a symbol. Here I'm gonna make a automatic one. I don't want any hustle. This is super good for me, no problems. Save the symbol and close. So now I'm gonna create a new cell. Call this schematic. And in this schematic, I'm gonna drag their new symbol. And there you go. And now to make a simulation, we need at least two things. We need a terminal with a basic port impedance. There you go. Let's put these guys right here. Not gonna look any good, but connect them. And of course, you need to simulate this to get the S parameters, so S param. And I went from 800 to 1 giga. Steps here are really important. We want definition, so we want 1 megahertz. So now it's the important part. We want to simulate this using real components, or at least the model for real components, not super ideal components. So what you're gonna do is download some manufacturer's database. They release these specifically for ADS. I'm using Murata components here, so I'm gonna use the Murata library. So download the zip file the manufacturer made available. Open the main window here. Design kit and unzip. I have this Murata here, so I'm gonna select it. You unzip. Of course, I've done this before, so it's going to tell me if I want to override it. I do. Of course, I want to use this in the workplace. Now I have a library here for Murata components. So let's just get, an inductor and a capacitor here. Just stop displaying this. Okay. And a capacitor. Let's get a GRM. Alright, we have our realistic models right here. Connect them to my ports. There you have it. You have the components assembled. Now I'm gonna use, of course, if I'm using specific library components, I need that library included here, like you're programming this in C. There you go, you have an includes. You are ready to simulate this circuit, so let's give this component some value. The capacitor can have a, picofarad. And the inductor, nanohenry. Sounds good. I'm gonna click right here in the simulate. So I will pick a rectangular graph for the S11 parameter in dB. There you go. Actually, really good already. And here, I want two parentheses. So save this. And now let's try some optimization here. First thing you want to do is make the components optimizable. So go to the end of the list, discrete optimize setting. And we don't need capacitors that big. Okay, let's make 12. And for inductor the same. Your minimal 1. Maximum 120, not that much. So first, for optimization, you need a goal. And our goal is to make dB value of S11 be smaller than a certain value. So let's make this 30. And to use optimization, we need the optimization controller. Let's make it discrete. And that's it. So they have the optimization and goal. I'm gonna click on optimize. But you can start tuning it instead of let it just run. And here you can tune the circuits in order to get the best results. Okay, just give me the main screen. Okay, there you go. You can see it's kind of difficult, so let's just use the axis here and make this. There you go, it's going to be easy. Okay, so let's see what we can do. Okay, there's a very optimal value here. And we destroy their circuits. Oh, the best result achieved is by this value of capacitor. Now we're gonna want auto scale this one. The details are just super small. Oh yeah, the best result is the smallest inductor as possible. So I'm gonna stop right here, stop the simulation and update the design. And you can see inductor is the first because it's the smallest value possible, and the capacitor is the 28th, 0.7 pico. So this is how quick you can set up the workspace, set up the environment, configure everything, and make your PCB ready to test with some realistic models of discrete components in order to find the best RF network. I'm not a specialist, I'm just learning RF right now. No, microwave is super new to me, but I decided to make this guide. Sometimes you just want to remember a small detail to set up the workplace for ADS, right? So I hope you learned something, I hope you find this useful, and in case of doubt, check Anurag's playlist. That he's the OG on ADS, best source. That's where I learned everything. And I'll see you later in the next tutorial. Bye bye.